In this problem, we want to identify the oxidizing agent and the reducing agent, and we have our reaction already written out for us. So to begin this, we want to assign an oxidation number to each atom in the reaction, so each atom in each compound. We'll start with our N2H4. We have a rule for hydrogen that is more important. So hydrogen's rule is that it is +1. So this gives us a total contribution of +4 from the hydrogen. So we have two nitrogens that have to balance that +4. So if we go -2 as the number for nitrogen, that would give us -2 times the two nitrogens would be -4, which would balance the four hydrogens at +1. We can ignore the coefficients as we go through this. In our next compound, N2O4, oxygen is more important than nitrogen in the rules. So the oxygen will be -2 by rule. And so -2 times 4 is a total of -8. And I've got to balance that -8 out over the two nitrogen atoms. So the -8 over 2 would give me a total of 4, and I need it to be positive to balance it out. So the nitrogen here is +4. When I go to the product side, N2 is a diatomic gas, and so because it's an element, it's going to have an oxidation number of 0. When we go to water, hydrogen's rule is more important than oxygen, so we'll start there at +1, and oxygen is going to be -2 in order to balance that out. We've now assigned the oxidation number for every atom in our problem. And now what we need to do is see who changes. What we see is that in the compound N2O4, we have nitrogen that goes from -2 to 0. And so here, because the oxidation number is getting larger, this nitrogen is being oxidized. Now, what we also have is a nitrogen whose number is getting smaller. That would be our nitrogen here. This nitrogen is going from +4 to 0. So since he's getting smaller, he's being reduced. Now, identifying what's been oxidized and what's been reduced will let us be able to assign oxidizing agent and reducing agent. N2H4 is being oxidized, so that makes it the reducing agent. Because the N2O4 is being reduced, it's the oxidizing agent. So there are two things to remember about this assigning oxidizing and reducing agents that are very important. The first is that both agents always have to be a reactant. And both agents are the entire chemical, not just the atom involved. These are both two big things where mistakes get made. The agent is always a reactant and always list the entire chemical as the agent.